Okay, all right, so we'll get started now. Hi everyone, welcome to Always Coding, our developer hacky hour. So again, hacky hour is a pun on happy hour, so feel free to grab a snack or a drink. I am having dark chocolate peanut butter cups. And today we are planning on showing the human pose estimator. So I'm going to show you how to deploy that locally on your laptops. And then we have Lila here to show you the Posture Corrector app. Lila, would you like to introduce yourself?
Sure. Hi, I'm Lila. I'm an R&D intern at Always AI, and so I build example apps like the posture corrector we're going to see today, and I'm excited to be here.
Thanks, Lila. Okay, so we can get started. I'm going to share my screen. So I'm just going to really quickly cover the setup process. If you already know this, hopefully this will be helpful for you. Maybe if this is just going to provide some additional color to what you already know. But if you haven't done so already, you want to sign up for Always AI. So you can go on alwaysai.co, and then instead of dashboard here, you should see a login button. And then you can click that, and then that'll give you an option to sign up. And then you can confirm your account and get started from there. Once you log in, it should navigate you directly into your dashboard. So it'll look something like this. And today, what we're going to do is we're going to create a new project. So we will call this Hacky Hour HPE. And this is going to be the human pose estimation. So let's create the project. And okay, Hacky Hour HPE was created, and we're going to click here to view our project. So as you can see, this project here gives you the chance to download the CLI for your Mac, or if you're using a Windows, you can download the CLI for Windows as well. Just to really quickly cover it again, if you see this pop up when you try to download the CLI, you want to just go ahead and bypass that by clicking Show in Finder, and then double click the app to open, and that'll give you the opportunity to open this app. And then same goes for Windows. It'll say something like, this is coming from an unrecognized app. You want to click run anyway, so you can start using Always AI and deploy computer vision on the edge. So with that said, as you can see, you already have the human pose model added into this project because that is what we selected. Now, if you wanted to use a different model or something you created, what you can do is go to the public model catalog, and then we can click pose estimation. And here, you will have the opportunity to upload your own model. And when you do that, then you can add that to your project by clicking add your own model. And it'll also be available in my models category here in projects and teams. But we're probably just going to use this human pose estimation model here. So let me show you how to run that. So you're going to pull up your terminal after you've downloaded the CLI. And I have created this Always AI directory. So I'm going to go in here. And then from here, I'm going to go into the Always AI starter apps. As you can see, when you go into the starter apps, you have all of these starter apps available for you to try out to deploy to an edge device. And for this one, of course, we're going to go ahead and do the real-time pose estimator. And then from here, what you want to do is copy this command and just click enter or hit enter.
I think we can't, or I can't see your terminal at the moment.
Oh, sorry about that. Let's see. Can you see it now?
Yes.
Okay, perfect. All right, so what we're going to do is go back to the terminal, and I'm going to go into the Always AI directory. And from here, we're going to go into the Always AI starter apps. Now, as you can see, we have all of these starter apps available for us when we download them. So what we're going to do is go into the real-time pose estimator, right? And then from here, what you want to do is you want to make sure you have this model downloaded. So just copy the model and then paste this here and then hit enter. So we've fetched the model, and we want to just specify that this is going to be in our app.py files. I have this pulled up already, and as you can see, this has already been specified here. And then from here, what I want to do is AAI app install. And that will install the app locally to my MacBook. And then from here, I want to do the AAI app start. So let's see. Okay, and it looks like it's working. So we're going to copy the streamer, and I'm going to paste this into my browser. And hopefully this works, and it does. So as you can see, you can just see the various joints of my body. Okay, well, that's it for my piece of the demo. And does anyone, before I move on, does anyone have any questions about setting up and deploying locally? I see one question here. Oh, AB, we can't see your terminal. Hopefully we fixed that problem for you. Any other questions about deploying locally? Okay, all right. Now I guess I'll hand it over to Lila to show the Posture Corrector app. I'm going to post the GitHub repo that Lila is going to show in the chat section. So if you want to follow along, just click on that and check it out. Lila?
Nice, thanks, Kamal. So as Kamal mentioned, we're working off a GitHub repo, and I have a few different versions of the app up on that repo under different branches. So the master branch has the basic posture corrector that uses the human pose model that Kamal just demoed. And I also have a branch up there called Nano, which will be the human pose estimator using the Jetson Nano. So first, I'll just briefly describe how we can set up a Jetson Nano, because it uses a GPU, which is a little bit better for stuff like pose estimation. But if you don't have one, you can just use the regular master branch. And there's another branch on there that has, it's called Extras, that has a couple extra features, and that also just uses Mac, Windows, Linux. Actually, it uses an audio file, which I know works on Mac. I don't think it works on Windows, but you can check out the code. Anyways, I'll demo it, and then if you want to change it for your Mac or Windows computer, then you can do that after the Hacky hour. Okay, so first, we'll go over how to set up a Nano, and I have a little Word doc that I'll share here. Oh, I need screen sharing enabled. So my Jetson Nano is already set up, and it's running, and so for that reason, I'm sharing pictures. Can you guys see my desktop? Is it too small?
You can make it a little bit bigger.
A little bit bigger here. Let's switch to desktop 1. That might be a little bit easier to see. Is that a little bit better?
Yep, perfect.
Okay, nice. So, so first of all, I want to point out that our blog page has all of the docs that I use to set up my Nano, and it has a lot of great tutorials for using the Nano, including the Posture Corrector app and using pose estimation on the Nano. So first off, Andres's blog on getting started with the Nano is perfect. It goes over everything you need. So I'm just going to kind of walk through it briefly. He lists all the stuff you need. You do need a monitor and a keyboard and a mouse. If you watched Hacky Hour last week, Eric did the headless setup with the Pi, but you need all these aspects for setting up with the Nano. It makes it a little bit trickier, but it's pretty simple. So he points out that you need a Wi-Fi dongle, which you can see here. I'm using the one that comes with the Cana kit. It was like $5 on Amazon, not bad at all. And so you also need a 32 gigabyte SD card, micro SD card, which is this little guy. They're pretty cheap as well, like, I don't know, $5-6, and some kind of adapter. So you have this bigger SD card, you can like stick it in there, or this thing came with the Cana kit for the Pi. So if you have one of those hanging around, you can use that and just stick it in a USB drive. And Eric showed how to flash an image onto an SD card last week, but briefly, what you want to do is download Balena, which I have kind of pulled up right down here. So you download the image. This is the one you want. Always check this page. We'll try and keep it updated. And you'll see these both here. This is the one you want. And you can notice in the little picture here, it has this file, and that's how I double checked that I was using the right one. So that's a good sanity check there. So you bring up Balena, you have that file downloaded, and when you select the image, it should just be in your downloads. You can see it right here. And you have your micro SD card plugged into your computer. It will just bring up the target automatically, usually, and if not, it's easy to find. And then you just click flash, and it does take like, I don't know, probably 20 minutes or so. So we're skipping that for today. But it's easy to do, and you can run the tutorial we're doing today on your development machine if you want, or you can catch up if you're doing it on your Nano. Okay, so once you've got that flashed, he shows you where to put it into the Nano itself. That's really useful. And this is another one that tripped me up, so this is really great of Andres to put it in here. If you're using a barrel battery adapter, which is, you can see the one I'm using right here, instead of the micro USB, you need to move this little, there's a little black jumper. You need to make sure that it's on both prongs. Otherwise, your Jetson Nano will not power on, and you'll wonder why that's happening. So once you get that done, you plug it in, you hook up your keyboard, mouse, your screen, and then it will power up and it will walk you through the installation process. I will say that you need to write down your password and username because you're going to need that, and it's important. And sometimes I just type in any old thing and then I forget. So once you get it powered in and set up, you'll see your username. You can type in your password, and then you'll see this boot up screen. And this is when you know you've done it right. It looks like that. And it's hard to see probably in this picture, but up in here, there's a little Wi-Fi symbol. That's how you need to set up your Wi-Fi and make sure you're on your network that your development machine is on. So you can click on it, pull down your menu, find the network you're on and configure it. If you miss that, if you need to, you can always go into settings here and find it. You can also see there's user accounts and devices. So that's where you can check your username and your device name if you need to, because you're going to need that to configure your device later. So I've just shown that where those are and what it looks like. You know, this is Lila01. If you want to change it, you can change it there, and then whenever you SSH in later. So once you have that, you can test your connectivity. So I have, you can kind of see that I already did it, but just to show. So the .local is for Macs. You shouldn't need that otherwise. But see, I'm in and I already logged in. It usually asks you for your password, but I did this really recently. And then to get out of that, you just exit. So that is the basic setup with the Jetson Nano. And are there any questions at this point about that? Is that a little too fast or too much?
Yeah, if anyone has any questions, feel free to raise your hand and we can unmute you as well so you can speak with us. Okay, Ian Cook is all good. All right, anybody else about setting up on the Jetson Nano? Lila, I think we're okay to move on.
Okay, nice. So the next step is actually setting up the project. And Kamal mentioned we're working off of GitHub. So this is the repo, and there's a few different branches. If you want to just clone the regular one, master, that's going to be something you can run on a Mac, a Windows, Linux. It should work for everybody doing everything. It doesn't have anything, any of the extras I added in, and it doesn't run on the Nano, but you can just clone it using git clone this URL, or you can just download a zip if you don't want to be synced up to the GitHub. Either way, so you would make a folder and CD into that and clone it into that, or download it. What I did for this is you can also clone a specific branch if you'd like to do that. So I have the Posture Extras and the Posture Nano. So what you do to clone a specific branch into a local repository is you do git clone single branch, and then the branch name, and then the URL. And then this last bit, Posture Nano, was me wanting to rename it so that I didn't get, if you just do it regularly, it's just going to call everything Posture Corrector, and that will not be good, and it will be confusing if you want to do the extras and the nano version. So if you want, I can paste that into the chat. And if you want to do just one or the other, actually, I have to get out of screen share to do that. Let's see. Nope. I think I can. Choose against. Let's see. Stop share. Okay. This is an example. You can change the name of that. You can change which branch you want. If you want to do the extras or the regular, that's an option there. So now, let's see. I'm in Hacky Hour. We're going to CD into Posture Nano.
We need your screen share again.
Question?
Can you share your screen again?
Oh, thanks.
No problem.
Desktop 1. Okay, is that okay? Can you see?
Yep.
Okay. Okay, so we're in Posture Nano, and Kamal showed you how to start a project on your dashboard. So if you want to just do the regular one, the master branch, or the extras, that will be sufficient because it has a human pose model. Otherwise, what you can do is create a new one, and you would want to not specify a model right away because we don't have the Jetson Nano in there, and also we're gonna be working from the GitHub. So you would do like test, start from scratch, next, and then don't select a model. I've already created my project, so we'll cancel that, but that would work sufficiently. It would just bring you up to a regular empty project. So right now I have Posture Nano, and so in your directory with your unconfigured project, you would still see this, and this is what you would use. You would type this into the terminal just like Kamal showed you, and then you should have my code from the GitHub repo configured with your Always AI project, and it shouldn't replace any models. You should have the Jetson Nano one there, and I'll show you what those specific differences were between the regular human pose model that Kamal set up and the one that you would be using for the Nano. So let's actually do that first, just because it's a little, nope. Okay, so you saw that Kamal's was just human pose. This one, now you can see it's human pose nano. And you can also see that we're using the TensorRT engine and the NVIDIA accelerator, as opposed to, what is it, DNN and CPU. Okay, good, thanks, Eric. So I will demo first. I just want to show that's the main difference, and along with this Docker file, whenever you're using the Nano, you want to make sure that the Edge IQ version is nano-014N. I believe the latest is 2, so we'll try and keep that updated in the docs. So let's see if we can run this. I'm going to do a remote device. And I have a saved device. It's Lila Nano. If you didn't have a saved device, you could configure your device right here by SSHing in, just like I did before with the device, my name, the device's name, .local. That's where I want it. Okay, and then we do a AI app deploy. hopefully this doesn't take too long. The first time you do this, it can take a long time because it has to pull everything down, but I cheated and did it earlier today. So hopefully it goes a little quicker. There we go. Okay. Takes a while to get it going. There we go. Okay, so there's a little bit of a lag on this guy. Can I see now? It's not beeping because I'm standing up straight. But if I lean forward, it beeps at me. And if I drop my head, it beeps at me. And if I slump down, it beeps at me. And you can see it's like giving me a little bit of like suggestions here. Okay, so that's really annoying. It's an annoying sound and it's annoying for a reason, so you stand up straight. Let's look at are there any questions about that or running it before I keep going? We'll look at the code more.
Yeah, there's a question from Sehul, so let's, hey Sehul.
Hey, hi guys. Can you hear me?
Yeah.
Perfect. So yeah, this is awesome. You know, I've been reading about that blog since a few weeks now, and I have a very similar idea. You know, like real-time action correction or posture correction for like construction activities. So my question to you is, how do you or maybe I should have asked, after your demo is done.
No,
but
no,
now that I've
yeah.
already asked, I'll just continue. Like, how do you compare it? What is right? Like, what is your ground truth?
Right. Yeah, and that's a really good question. And my ground truth is, like, for posture will be different than somebody else's, and it will be dependent on the camera setup. So when I first built this, it was with the webcam on my Mac, and then when I used the webcam for the Nano, I had to put the camera in a very similar position because it's like on my left. I tried to get it so it was like the left or the right, but that's a really good question. And let's look at posture.py to answer it. So posture.py is the Py file that I wrote to actually do the logic in the posture corrector. And it's separate. It keeps it a little modular. It keeps it easy to change things without breaking all the code in app.py, because you just know that the function returns what it's supposed to return. And however you do that in the function, it won't matter if you change that later. So you can see that here, and maybe I should also start, this is very similar to just the regular human pose, the real-time pose estimator. Nothing has really changed. The only stuff that has changed is this configuration setting, which I borrowed from Jason's app. It makes it really easy to change things in your app without completely having to rebuild the containers every time you want to do something. So I'm using something called scale, which goes into Sale's question about the ground truth and how you can kind of make that a little bit more generalizable. So this is just a little bit, neater to define these global variables up here, and then you can access them later down here in these local ones. So this is a function that Jason wrote to just read in the configuration file, access the variables. You can find it on the blog page in his article using a configuration file. That's really helpful to have. And so after we set up our pose estimator, then right here is where we use that scale variable to initialize our posture corrector object. And I don't know how many of you are coming from like an object-oriented background, but that's kind of the logic here. We're creating a posture corrector object that has this key points variable that holds all the key points passed in from the pose estimation model, and then it just has the scale and the message, which is how we got that personalized message, hey, sit up, lean back or lift your head up. So that's a lot to unpack. If there's any questions, I can pause, but I promise we'll get into the more like key point stuff in a second, if any of that was a little bit too much. Are we okay for now?
Yeah, I think we're okay for now.
Yeah.
Unless anyone else has any other questions. Oh, sorry, we have one more question, Lila.
Okay.
This is from M. Hey, M.
I think you're muted. you want to unmute or type?
Okay, I think we can move forward. If he changes his mind, we can always bring him back.
Sounds good. Okay. So, so what we do, some of these are getters and setters. They might be not necessary, but I'm used to putting them in, so they're in there. Here are the 3 functions that I defined, which do the heavy lifting for the posture corrector. My poor posture behavior, aside from just having chronically rounded shoulders, is like leaning forward to my computer instead of like making the text bigger on my screen and looking down at my phone, or just getting lazy and like totally slumping down in my chair. So what I did to get started with this is, first of all, the YMCA app blog was really helpful in just kind of getting my bearings around where the key point, like how to access the key points that they actually, you know, from Always AI's kind of logic, you know, using the API and figuring out how to call things. So that's a very helpful starting point. And I tried to incorporate that into this blog post, but if you need extra help, that's a good starting place. And then what I did is I just printed them to the screen. I printed the coordinates to be like, okay, where is the upper left corner? Where is the bottom corner? Where am I like falling? How is my nose different from like my chest or my shoulders? And so I could see that, okay, logically, when I'm slumping down, my nose is very similar, or it's much closer to my neck position, only on the Y axis, not the X, you know? So that's how this one was done. You know, if your neck Y is, and your nose Y are not -1, which means the model did detect them. That's always a good thing. You don't want to be looking for stuff that isn't there. Then if the nose Y is much greater than the neck, minus, this is the 150, which is I for my ground truth, it's like, okay, 150 was about the difference before I was slumping. And then you can set the scale. So if somebody passes in a scale that's bigger, maybe you're taller, maybe you need more distance between your nose and your neck, then this will automatically give you a bigger buffer so it won't make that annoying sound at you when it doesn't need to. So that's kind of that part of the logic. That's like a simple version. And are there any questions about that before I move on to the other 2?
Yeah, it seems that M is still raising their hand. M, would you like to talk or ask your question? Okay, I guess no. Well, if anyone else has any questions, just feel free to raise your hand.
Yeah, if you're having trouble with your mic and you want to just type the question in.
Oh, he said
that.
yes. Okay. You should be able to unmute yourself, M.
Oh.
Okay, I think he's unmuted. Hey, M? Hello? Can you try to say something, M? Okay, I'm gonna mute you for now, M. We have another question from AB. Hey, AB.
Hello, hi. So this is a very interesting app which you built. Can you hear me?
Yeah.
Okay. What if we could use a depth camera and then we could have got the height and all that? We can do a lot of measuring. Can this be made into a dynamic pose estimator rather than instead of passing the scale?
Yeah, that's a good question. And when we were creating it, another intern was using the real-time, the RealSense camera. And so we wondered if that would work better. I don't know much about the RealSense camera, so maybe I'll let Eric take a stab at this.
Yeah, I can jump in. Yeah, so I think you could do some pretty cool stuff with the RealSense camera here. That might be like a pretty cool app and an extension to build on this as well. I think, of course, not everyone has a RealSense camera, so a lot of it is kind of like making things work with what you have. So, but yeah, if people are interested in the RealSense camera, I think be neat to try some of this stuff out with that for sure.
Yeah, of course. Yeah, that kit is really expensive. Yeah, I think the OAK-D is coming for the rescue, I think.
Yeah, that's right.
Yeah, so maybe we can convince Alistair to make his own posture corrector or some other. He has a really cool RealSense app that just does distance measuring, but maybe he can do some other stuff that sounds like people are interested in doing that more depth camera stuff. But yeah, this app will get you by using, you know, just the 2D space with what you have. And it shows that you can do quite a bit with it if you get a little creative with how you're manipulating these things. So like lean forward goes from like the left or the right, depending on which angle your camera was on. And it just says like, okay, is your right ear too much farther away from your shoulder? And that would mean like your head is being stretched. And kind of the same thing for drop, you know, it's your eye's position with your ear. So, you know, you can see like as soon as your eye is level with your ear, then your head's too far down. And obviously like maybe some people's ears are higher on their head or whatnot. So it's not perfect. They'll have to like tweak this. And if you think of a better way to do this, you can make a pull request on the GitHub. That would be great. We love collaboration, and I'm happy to have my code, you know, nice, ripped apart and put back together. So what this function does is it checks all of them. So it will return true only if all your posture is great. And if any of them didn't return true, it will return false. And so back in app.py, we can see if you don't have any correct posture, then we want to get the message to display to the user to help, you know, provide some guidance, not just beep at them annoyingly. So that one, it's a little redundant, and there probably could have been a more efficient way to do this. It checks each one of these, which has already been checked, but it checks them and it will update the message accordingly. So if you have 1 or 2 or 3, any combination thereof, it will check them all and update your message and then send it back, which we can then append to the streamer text, which we already saw. You know, the starter app comes with these text append so that you can print out all kinds of useful messages. You can print out the key points, you can print out other stuff, help you debug, help you get more comfortable with the APIs and the models themselves. So I found that really useful. And then we print this really annoying sound using print/a. And that will work. It should work for Mac, Linux, Windows. And for my extras version of this, is there any questions about the Nano version before we move on to the Mac other version?
Actually, Lila, I think M was able to figure out his microphone issue. So I'd like to hear what question he has.
Yeah.
If that's okay. M, I think you can unmute yourself now and we can try one more time.
Yeah, hello. Can you hear me?
Yeah.
Hey.
Finally.
Sorry.
So my question was, this thing works in Raspberry Pi?
Good question. It does work on like a Mac. I didn't try it on a Pi. Is there any reason, Eric, it wouldn't work on a Pi if you just switch the engine back to DNN?
I think because they are using the operating system and engine.
Yeah, I think if you use the one on the master branch or probably the extras, it would work. I think it would be pretty slow, so I would recommend getting like an NCS2, which is the neural compute stick. I think we have some stuff on our documentation about that. I can add to the chat if you're unfamiliar with it. And basically, that would give you some pretty good performance on a Pi, I think. In the test that I've run, at least with the human pose model, it looks pretty good. So that's what you wanted to do. I think you could get it to work.
So I have to download some tools or package?
Sorry?
I have to download some tools or package on the operating system?
So I think all you would have to do, so basically if you want to get the better performance, So I guess to start, you could just install the app from the master branch on a Raspberry Pi using our tools, and it would work right out of the box. If you wanted to use the NCS2, you'll need to buy one. I think they run like $70 or something like that. And it's just a USB stick you plug in. And once you get that, you just have to change one line in the code in the load command. You would just change the engine to be DNN OpenVINO. And from there, you would see it would run the inferencing on that USB stick, and you'd see a big boost in performance.
Okay. Thank you very much.
Yeah.
Thank you.
Yeah, and I'll send you a link to where you can get the NCS as well, if that's helpful to you.
Okay, sure. Thank you.
Lila, we actually have a really interesting question from Nadia. So Nadia says, I want to activate keystrokes or joystick controls based on the pose to control a game. .exe file. Have you tried this?
I have not.
That's a cool idea.
Has Eric? Have you?
So yeah, so one of the things that you have to consider, and this is something. Okay. So Steve, who might be able to chime in or may not, probably has more familiarity with this, but one of the issues that you would see is that if you're running the app using our tools on an edge device, it's running in a containerized environment. And so it's not super straightforward getting keystrokes in and out of that. What I would recommend and what we've done with the streamer is kind of building a web interface where you can, so that you could build like a Flask app, or you could even build a Node.js app that communicates from another container to your Python application, or something along those lines. And from there, you could build something more interactive. The one thing you could do is on the native installs, which are like the Linux and Mac desktop install, or sorry, the Windows and Mac desktop installers, you can use the more interactive pieces just because it's running directly on your system. You just have to understand, you have to use the Python version that's been installed to go along with the alwaysAI development environment. So that's going to be in, if you look up the environment variable alwaysAI home, that points you to that development directory. And from there, you just want to make sure that if you have to install or anything, you use that Python version. But I think you might be able to just still use the tools and just kind of work with it that way. I guess the point is, if you need to run your app directly, like a Python app.py, you'll need to make sure you use the Python that's installed in that dev environment. And you can reach out to me on Discord if you need more help on there. It's not really the recommended workflow that we have. I would definitely push people towards like the building something out in the more like web direction, if that's what you're going for. So.
Steve, did you want to add anything to that?
No, Eric captured it. So if you're going to do something like Pygame and make it, then it needs to be in either a Mac or Windows system, because we're containerized when we're running out on more edge devices. And like Eric was saying too, you could probably use some type of web services type of Python library to push out any of the XML stuff or any of the data that's coming through that into a web-based application. And then that's where you can start to interface with these other types of tools.
Sweet. Okay. Okay, Lila, you can.
Cool. Yeah, so if we're okay with Nano version, we can run the extras version, which is just a little different. So for that one, if you want, I can post this in the chat as well, but all you'd have to do is replace Nano with extras and Posture Nano with Posture extras. And so that one, we're gonna do, let's see, and where's my, okay, we'll demo it first. Oh, so you can create a new project if you want. for that one. Similar to how we did before, just do new project and then give it a name, Posture Extras, whatever you like, start from scratch. For me, I already did that. So I'll go into the one I created. There we go. So you'll see your own AI app configure link. You'll paste that all in, which I've already done. So I'm just going to do configure. And this time I'm going to say my local computer because that's where I want it. And we're done. Okay. App install. Start. Okay, hopefully. And this one's going to use my voice. So I have a child's voice when it's recorded. Just be nice. Okay. Okay. There we go. So this one you can see gives you some like, it's saying that my eyes are too low, that my nose is too low, or that I'm leaning forward. There's the difference between like my shoulder and my ear. And now it's happy with me. And I'm going to shut it off because it makes my CPU run a little too hot while it zooms on. So that was that one. That was just like a little extra. The sound one is kind of fun. You can create your own audio files. You could have different audio files for different things. Like if somebody was doing the YMCA app, maybe you could play the YMCA song when they do the YMCA pose, or maybe you could say, hey, you're doing a Y or an M. So you could have all these different files. Then you could configure them in your config file. You could have different settings here. You could toggle them in and out. That would make it really easy. The main thing I wanted to show with this is that you can use the starter apps in a really versatile way. You can mark up the image. You can use Python libraries. To use this setup wave file, all we did was import a package and then put it in a requirements file. This gets automatically installed in the virtual environment when you do AI app install. So that's really easy. You don't have to worry about anything besides making this file and just putting simple audio in it. You can do that for any Python package. And for system dependencies, you can always put them in the Docker file, and we have all the tutorials how to do that up on the docs page on the website. And there's even blogs, you know, how to switch these things in and out. So we want to make it really easy. And then the extra thing I added for this one was I did change posture.py, which again was really easy. I didn't have to modify app.py hardly at all, and I didn't break it because everything was self-contained in here. So this time I separated out the key points, which is a little redundant looking. There's probably a cleaner way to do this, but I also did it just like yesterday and I didn't want to break things too much. So now you're just appending these points to a dictionary, well, two lists within a dictionary just to save the points. And then you can use those key points that are returned by the model to draw all kinds of lines using OpenCV. All you need is 1 point, and then you can say, okay, X minus this or X plus this or X and Y together. It just shows that you can do a lot with what the model gives you back if you just, you know, use your imagination. And so in draw.py, all you do, I should have added some comments, I'm sorry, some doc strings. All you're doing is you're just using OpenCV or CV2, and you're just drawing lines. This is the starting point and the ending point. So you can see this is how you draw an X. You do, you know, one data point down, the next data point down. And then this one is a line, 2 lines to kind of create a square. I didn't do a diagonal one because then it kind of overlapped with the key points lines in the, like what's returned by the model. So, but you could do anything. You could change the color. This is red, obviously, but maybe you wanted to add red for bad and green for good. Maybe you always want the lines there, and then instead you would just have posture.py always add these data points, not just when your posture is bad. And then you can just add one function to return those points. And I reset it here. Otherwise, you're going to get every point you ever added to it, which I always forget to have. If you're like me, then you'll remember. So new data just makes a new data dictionary. Again, there's probably a more elegant way. And if you have a more elegant way, please do show me how on the Git repo. Just make a pull request. And that's about it. If there's any questions or suggestions, and you can see here, all we had to do is add this to play the sound. And this was already the draw points. You know, you just add one line to draw the points, and you add this block to play the sound. Are there any questions? Or
we actually do have another question from Sehul. So Sehul, you should be able to unmute yourself now.
Yeah. So yeah, again, like, you know, this is great. And I've, like I said, I've been working on something very similar. I want to, you know, do a real-time posture correction for exercise, right? Just, you know, and this is an open question, you know, if Eric and if you guys want to jump in as well, is how would you, despite somebody's, you know, height or width, right? You know, because my X and Y coordinates would be different than yours. So of course, you know, that file would not work for me or somebody who is like a 6 feet tall, right?
right. Well,
how would,
that, like, in chairs, everyone's height is kind of standardized, but I do see your point that, yeah, like, you know, depending on where your webcam is,
yeah.
I think in terms of like width and, you know, actual height, it's you can estimate given, like, you know, other objects in a room, but it's trickier without something like the RealSense camera, and maybe Eric or Kamal have a better answer to that. But that's kind of what I was trying to do with the scale, is to, like, okay, maybe you could do something else besides the scale, some other kind of normalizer, or maybe different arithmetic that's less dependent on somebody's height.
So one of my thought is that, you know, basically take this, whatever the output of this model is, or, you know, the you know, the X and Y coordinates, right? And then figure out which one, which of the points has the most motion, you know, like, you know, and create a different deep learning model, like a CNN model that tells you, oh, the most important points are the legs because they are moving a lot in terms of, you know, a squat, right? So concentrate on that. And then, you know, again, but what I'm trying to do is, you know, I'm trying to figure out, like, but to compare it, there has to be a ground truth, you know, there has to be the world's best squat, right? For it to compare it with. So that's what I'm trying to figure out, like, how do you, there has to be a world's best, you know, or almost perfect chair position.
Yeah, I guess it's kind of hard too, and I think you kind of like nailed it when you were talking about using like a secondary model. That's something we've kind of discussed too with a lot of this, because when you get these data points back, you know, like there may not be like, well, there probably is a world's perfect squat, but maybe there are multiple people with different body points or body types that are all capable of a world's perfect squat, right?
Yeah.
So one way that you could do something like that is if you had a lot of good data, you could get these data points, and you're not even doing image processing anymore at this point. You're just doing like, you know, data processing. You plug in those the data points, the key points you get back into some sort of classifier, and you could basically train another model on that to determine, okay, if you fall within the, you know, the thresholds that model determines to be a good squat or not, right?
Yeah. And
Eric, this is Steve coming in. I don't know, possibly if you could do a person detector, right? And you could get the XY axis, and as they're squatting on this, knowing how much offset are they, you get that, what I would call ground truth XY axis of what a person is in that bounding box. And then you could kind of tell off of movement. And I think some people did that at a hackathon with a yoga application, if I remember right, using pose estimation. But they just combined two models, and I believe they used a person detection and then watch how that person moved off the XY in a relative session. So that might be an approach.
Mm-hmm.
Okay.
Another thing, I'm not this might be implemented in the YMCA app, or it may not. I don't remember. I haven't looked at that actual source code, but I remember talking to Andres a lot about it when he was building it. And one thing that he talked about was kind of the same problem that we're facing. And the question, so we thought of a secondary model, but an easier solution is how do you kind of dynamically determine what that scale factor should be, right? And so I think what he had tried he had tried a few things about finding some ratios between different points on a person's body to try and characterize what that scale factor should be for that person. So that could be like, you could look at like the length of someone's arm or the length of their neck or something like that, and kind of use a few of those different points to determine a scale factor that makes sense. And you'd still have to do a lot of testing, but that might be some way that you can kind of make, the more expert system approach, where you're saying, okay, you need your knee bent this way, but then a tall person and a short person, that might look differently. So we're going to check the ratio of their leg length and use that to find a scale factor that makes sense. Something along those.
Yeah. And again, the more I think about it, I've been thinking in something very similar regards. You use the word ratio. I was thinking about the word angle. Mm-hmm. And the angles, because, despite somebody is, 5 feet or 6 feet or 7 feet tall, the angle for a particular posture would be the same. Right. If the bend needs to be 90 degrees, it doesn't matter what your height or, we are with, it is going to be 90 degrees. So I was thinking in that regards maybe, but
yeah,
and then
really good.
And I have one last question. I don't see how RealSense camera is going to be used. Maybe I'm missing something. I happen to have one, the D435i, but that's just a stereo camera that gives you the depth, right?
Right. So I think what you could do with the RealSense camera is you could make things a lot less dependent on the camera location. For example, you could have a RealSense camera that's sitting directly in front of you, and it would be able to tell you, if you're leaning to the side or if you're leaning forward, which currently with the regular webcam, you wouldn't be able to get like that third dimension of like leaning forward, or like if you put it to the side, you might be slouching to the side, or which, like in this example, we can't really detect because we wouldn't know, you're just closer or further from the camera. So that piece, I guess I see it enables more cases you can check, but also just makes it easier to place the camera. You can get a more precise like reading of how someone's leaning.
So basically, yeah. So use the distance from the camera, right? Because those are all color coordinated, right? If I'm closer to the camera, it's going to be blue. If I'm further to the camera, it's going to be red.
Right.
Okay.
And then talking from like an angles perspective, in this example, looking at like a 2D piece, you can get kind of an angle on a 2D plane, but that would actually allow you to get an angle on a 3D plane in some ways, right? Which would be more accurate.
Okay. All right. Yeah. Thank you, guys. I appreciate it.
Yeah. Thank you.
Thanks, Sahil. So the next question is from Usama. Usama, would you like to ask your question? Usama?
Hey, can you hear me?
Hey, I think we're having some trouble hearing you. Okay, Osama, we'll come back to you. So this next one is from Leo. Well, yeah, Leo, we'll share a recording after this, no worries. We have another question from Alok. He asked, can you do multiple people in the same frame?
Yeah, I don't know. Like you can see there's another person's desk set up behind me. So sometimes that chair is occupied and it would pick up both of us. But kind of like what Eric was talking about and Sayul's question about the RealSense, it might not, with the camera angle, it might not correct his posture in addition to mine because the key points, you know, like the angle and stuff. But especially in pose estimation, it will detect multiple people. And you can even see that here, person, I left this stuff in just because I thought it would be useful for people to see. It will pick up multiple people and give you the key points for each person. And then in the screen here, it says person 0. So the next person would be person 1, person 2. And with better maybe logic on my part or the RealSense camera, then you could fit this app to having multiple people. It would just depend on the camera angle and how the people were in the frame. Did that answer the question?
Totally. And he said thanks as well. So the next one is, what's the best performance you could expect?
I think Eric might be able to give you actual numbers because it sounds like he's done actual tests. The Nano, you could kind of tell, like on my Mac, it will have like a delayed effect, and sometimes I'll have to refresh the browser, and sometimes it will still be yelling at me to correct my posture, even if I'm sitting up straight, because it's got a bit of a lag. But the Nano does seem to be a little bit smoother. It will give you the inference time as well, usually when you see it says prints out the inference. So you can kind of run these experiments yourself and test which engines or accelerators or give you the better performance. I don't know, Eric, is there more that you want to add to that?
Yeah, I'm trying to dig up our regression numbers, but I don't remember where they're being saved right now. They're often they're getting saved on some server. So as for the Pi, I remember it being like I'm pretty sure it's faster than 1.6 seconds FPS. Or sorry, yeah, 1.6 FPS is what we're seeing, right? I think if you use an NCS2 on the Pi, on Pi 4, it's going to give you better performance than that. I thought the Nano one would be faster, but maybe that's not the case. I don't know.
I thought so too.
That one. So I can dig through some numbers and try and figure out exactly what we expect to see there, but
Hey, Lila, this is Steve. Did you use the TensorRT model on the Nano? Do you know?
I did, yeah.
Okay. Then Eric, you ain't going to get much better than that on the Nano. So that's what I wanted to make sure.
The Pi was faster. That's why I was surprised. The Pi was
weird. Maybe I should have done it on the Pi. Next time, we'll do an experiment.
Yeah, I mean, I guess I have one like sitting right in front of me, so I can run a test real quick. I'll figure that out. But we only have a minute, so I guess I'll have to post it on Discord or something.
Okay, cool. George did respond back saying he got about 30 frames per second using the model out of the box via OpenVINO on the CPU, but he was curious to know if there's any lag from the extra Docker layers in between.
If there's any what?
Any lag with the extra Docker layers in between?
On Linux, there shouldn't be. I mean, it should be. It's pretty much the same as running on straight on the OS. Lag would come from running it. Well, yeah, you just on an ARM device, it's typically going to be slower if you do like the CPU or GPU option on like any of these devices that we have, compared to running it on your laptop. You'll typically get pretty good performance out of most of them on your laptop CPU. So yeah, so that could be a big difference. I wouldn't expect Docker to be really impacting that.
Okay, cool. Osama has actually written out his question. He said that as you guys use distances between nose, eyes, and neck for the positioning of the body in a chair, how can you, he's asking, how can you model for voice detection or differentiating between different voices? So as far as I'm aware, we don't support voice detection. We're only computer vision. Lila or Eric, would you like to elaborate on that?
That was my understanding. I'll let Eric field that.
Yeah, if you want to talk about different, the cocktail party problem, you can hit me up on Discord. That's a famous one. But yeah, so all the models that we have right now are computer vision models, and we're focused on that workflow. That doesn't mean you can't bring other models into these apps. You could absolutely do that. I've used Keras quite a bit, not with our apps. I'm interested. I should probably test that sometime and see if you can load Keras in and everything works. But if that works and you're familiar with that, you can definitely bring in your own audio models or any other piece like that, and build that into a computer vision app too, if you were using multiple factors to differentiate people or whatever you might choose to do.
Awesome, thanks. And then we have one more question from Leo. Any date when the neural accelerators might be supported under the Windows, Mac, Linux, assuming they're still not supported? We don't have a date on that yet, right?
So as for the neural accelerators, so for like Windows and Mac, the performance will actually be slower on those systems than running natively on the CPU in most cases. I guess I'm making an assumption that your laptop's like fairly recent or whatever, but you should see fine performance there. Now, if you're on Linux and you use so on Linux, we don't support a native one. We support a Dockerized one, just like going to an edge device. And so in that case, you can use the NCS2 and as well as on the edge devices. And so right now, I don't think we really have plans to bring NCS2 support onto the like Mac and Windows native platform. But if there is a lot of demand for that, we can consider it. But performance-wise, I think you'll probably see it run slower in most cases.
Cool. I'll send out the, so M is asking, can I save person's information, which I'm assuming is our information. So you can join our Discord channel for additional questions, and I'll also send out a recording after this. And if you have any additional questions, you can always email me. With that said, I think we're about ready to wrap up this session. I just want to thank everyone for joining. If you enjoyed this and you like asking questions, if you like this interactive format, please join us again next week, every Thursday at 2 p.m. For weekly Hacky Hour. And just before I let you guys go, make sure you sign up for our upcoming webinar, which is Model Training Made Easy. So you'll learn how to build train your own computer vision model and deploy it to an edge device. So if you have any questions about that, feel free to reach out to me directly via email. And I'm going to send out details about this Hacky Hour via email as well. So thank you so much for joining, everyone, and we'll see you next Thursday. Bye, guys.